Okay, so now that we understand what a radian is, when we look at a page of problems like I have here, this should feel like I'm asking you the exact same things I asked you previously in Skill 3. The difference is that each time you look where you expect the angle to be given, you see the angle given to you in a different unit of measurement. So that's going to be our goal today. So remember, the things that haven't changed is that we can still use our unit circle as a tool, and that we still should know that the sine of an angle is equal to the y value on the unit circle, the cosine of an angle is equal to the x value, and the tangent of an angle is equal to y divided by x. And we should know the reciprocals of those, that the cosecant of an angle is the reciprocal of the y value, that the secant of an angle is the reciprocal of the x value, and that the cotangent of the angle is the reciprocal of the tangent, or y divided by x. So I'm still trying to get to these positions and use that to interpret what's happening there. The difference is that the positions are given to me in these radian measures, and I have to know how to get there. And if you're using your unit circle to do this, we are learning it right now, but remember, the expectation is that you know the unit circle. So as I go through these examples, I'm going to do them as if I have my unit circle memorized and I'm figuring out stuff from there. Okay. All right, so tangent of 5 pi over 6 means the first thing I want to do is identify the location of 5 pi over 6. Now, in my head, I know that on the unit circle as radian angle locations, I have that associated with 30 degrees. So I already expect 5 pi over 6 to either show up at any of these locations, that are 30-degree locations. Okay, that's the idea that I have going on in my head, just to give you guys an idea of how I wade through the unit circle. Then when I see 5 pi over 6, I try to associate it with something I know. I could either start counting by chunks of 30, because 1 pi over 6 is equal to 30, and I could count 5 of those chunks. Or if I think of this as 0, this is pi, and getting all the way back is 2 pi, in terms of 6, pi is like the same thing as having 6 pi over 6. So that when I view 5 pi over 6, I view it as the 6th that happened right before 6 pi over 6, meaning it didn't make it all the way to 180 degrees. Instead, if this was where this angle started, it went in the positive direction and it made it just before that. Okay? And then because I know it's a pi over 6, I know that that's 30 degrees before that. And with my 30 degrees, remember, I know that it's these numbers. And if I struggle with which one is which, 30 is across from the shorter distance, so that means this is the short leg, the y value. So the y value here is the 1/2. The x is the rad 3 over 2. And because I'm in the second quadrant, it'd be negative rad 3 over 2, comma 1/2. So I'm just trying to give you guys a little review of how to get there. Encourage you to memorize your unit circle. So remember, tangent is y divided by x. So in this case, that would be 1/2 divided by negative rad 3 over 2, which is 1/2 times negative 2 over rad 3, which is negative 1 over rad 3. And we usually don't keep our answer in this format. We would normally choose to multiply by this 1 to rationalize it as negative rad 3 over 3. All right, next up is cosecant of negative 3 pi over 2. So I know that pi over 2, again, the scratch work that I'm writing down kind of messily, I'm just trying to give you guys an idea of what goes through my head if you're struggling with memorizing the unit circle. So I know that pi over 2 is 90. So 3 pi over 2 is like 3 chunks of 90. Okay? And again, this angle is negative. So this would be like going in the negative direction, 3 chunks of 90 degrees. So that would land us over here, our terminal side. And I know the coordinates at that position are 0, 1. So it's asking me for cosecant. So to find the cosecant, I normally actually find the sine first. The sine of negative 3 pi over 2 is that value of 1. The cosecant is the reciprocal of that, and the reciprocal of 1 is 1. All right, for cotangent of 16 pi, Notice it's a whole number of pi. So my approach to this one, I would use the fact that I know an entire lap around the circle is 2 pi. So if I'm starting here at 0 and going in a positive direction, once around is 2 pi, then 4, then 6, then 8, then 10, then 12, then 14, then 16. So I don't do this every time, but I'm just trying to make a point to you guys. But 16 pi is going to land right back here at 0. And the coordinates there are 1, 0. The cotangent is the x-coordinate divided by the y-coordinate. So that would be 1 divided by the 0, which is undefined. All right. Next problem we're going to look at, sine of negative 11 pi over 6. So again, I want to understand where negative 11 pi over 6 is. And for me, again, I'm going to think about 0, pi, 2 pi. Negative is going in this direction. And I want to think about it in terms of sixths. So pi is like 6 pi over 6. 2 pi is like 12 pi over 6. So when I see 11 pi over 6, here's how I'm interpreting it in my head. I started at my initial side, I'm going this direction, and 11 pi over 6 is almost 12 pi over 6. It's almost the entire whole lap around the circle, but then it stops just before it reaches that 12 pi over 6 and leaves a pi over 6 amount here. And I know pi over 6 is 30 degrees. So again, that helps me establish that the coordinates here are rad 3 over 2 and 1/2. The sine is the y-coordinate, so that will be 1/2. So next up is the cosine of 19 pi over 3. So this is slightly different. Remember, a pi over 3, I'm thinking about those 60-degree locations. So just to give you perspective, I'm expecting, since it reduced down to a third, for it to land at one of these positions that's 60 degrees away from the x-axis. That's my expectation, okay? And again, I'm going to use some version of thirds to help me understand this. So 0, pi, and 2 pi, start with that. And if I think about these in terms of thirds, pi is like 3 pi over 3. 2 pi is like 6 pi over 3. So one whole lap around the circle in the positive direction is 6 pi over 3. That's not even close to 19 pi over 3. So I'm going to go another whole 6 pi over 3. 6 plus 6 is 12. So I've gone 12 pi over 3. I can still go another whole 6. So when I do that, that's 18 pi over 3. 19 pi over 3 is what I'm trying to get. I'm at 18 pi over 3. I need to go one more pi over 3. That's one more 60 degree. So it's going to land right here on this terminal side. And remember, it's a 60, that means a shorter x value and a longer y value. So that means the x is 1/2 and the y is rad 3 over 2. The cosine is the x-coordinate. So that means that in this problem, the answer is 1/2 because that would be the cosine of 19 pi over 3. All right, so for the next one, we want to calculate the secant. And remember, think in your head, okay, secant is the reciprocal of cosine of negative 9 pi over 4. So again, I see a fourth, and I'm just trying to give you guys some perspective. Fourths are what the 45-degree angle locations reduce to, so I expect it to land at one of those 4 positions. It's negative, so I understand that from my initial side, I'm going around the circle clockwise, and then I can either count pi over 4s, or again, I can use those spots I know really well as reference. So 0, pi, 2 pi. If I think of these in terms of fourths, pi is like having 4 pi over 4. 2 pi is like having 8 pi over 4. So when I look at what I'm trying to go 9 pi over 4. That means I can go an entire time around the circle because that's 8 pi over 4. And then I just need to go one more pi over 4 to reach 9 pi over 4. And that would land me here because remember I was going in the negative direction. And then for pi over 4, I have memorized that the coordinates there are rad 2 over 2. And being in this quadrant, that would be a positive x value and a negative y value. Okay. Secant is the reciprocal of cosine. So I'm going to remind myself what the answer would be if I was looking for the cosine. It would be rad 2 over 2. And I'm going to use the reciprocal of that for my secant and rationalize if I have to. Some of these, if you've done them enough time, I understand that you might know what the reciprocal is very quickly, but I'm just trying to be very thorough. All right, we're going to do 3 more. So the next one we're going to look at is the tangent of 15 pi over 4. So again, this relates a lot to the last one that we just did because it's another pi over 4. So my expectation is one of those 45-degree locations. And again, this is 0, pi, and 2 pi. But I'm going to think about those in measurements according to fourths. This is like 4 pi over 4 and 8 pi over 4. And this is positive, so I understand that from my initial side, I'm going counterclockwise to get 15 pi over 4. So 1 entire lap is 8 pi over 4. So that's fine, I can do that. If I did another entire lap, that would be another 8 pi over 4, and 8 pi plus 8 pi would be 16 pi over 4. That's a little bit too much for this. So I can go one whole lap and then not another whole lap. So you can think about it 2 ways. One way is you could say, okay, I'm trying to get 15 pi over 4. By going one lap, I've already gone 8 pi over 4. That means what's left is for me to go 7 pi over 4. Okay. So to here would be 4. And then I know 45s are pi over 4. So 5, 6, 7. It's going to land me right here in this 4th quadrant. And again, I know the coordinates there, and the y coordinate would be negative, given where it's at. And tangent is the y coordinate divided by the x coordinate, and hopefully at this point you're comfortable with the fact those are the same values, so when you divide you'll get 1. So our solution there is negative 1. For the sine of negative 5 pi over 3, it's a pi over 3, so again, just a little perspective. I have an idea of where I expect it to land, and then this is 0, pi, back to 2 pi. In terms of thirds, that's like 3 pi over 3 and 6 pi over 3. Notice that 5 pi over 3 is less than an entire time around the circle. So this is my initial starting place. I want to go negative, so I want to go in the clockwise direction 5 pi over 3. So an entire lap around the circle would be 6 pi over 3. So there's a couple ways you guys can think about this. I'm going to think of 5 pi over 3 as being 1 less than completing the entire circle. So I go around, I almost complete the circle, but I don't. I land in this quadrant, leaving pi over 3 left, the extra pi over 3 I didn't get to go. And I know in my mind that that's 60 degrees. So I then know the coordinates here are 1/2 and rad 3 over 2, both positive. The sine is the y coordinate. So the sine of negative 5 pi over 3 will be rad 3 over 2. And then lastly, we're going to do the cosecant of negative 17 pi over 6. So again, when I see that 6th, I'm thinking about 30 degrees away from the axis. It's kind of where I expect to be. And again, I'm going to use for reference my 0, my pi, my 2 pi. And that in terms of sixths, those numbers that I'm thinking about are like going 6 pi over 6 or 12 pi over 6. So when I see that my angle is negative 17 pi over 6 from my initial side, I'm going to go clockwise. If I go an entire lap around the circle, I've gone 12 pi over 6. I cannot go another entire lap because 12 plus 12 would be 24, and that's too many. I'm only looking for 17. Okay, so I need to go 5 more pi over 6 or 5 more 30s, which would be like 150, which is just 30 degrees less than 180. Puts me right here, 30 degrees away from completing that. And again, the way I was able to bounce between a radian and a degree there is that I know a pi over 6 is a 30-degree measurement. So the coordinates here would be an x of rad 3 over 2 and a y of 1/2. And given that it's in the third quadrant, both coordinates would be negative. And then I'm looking for the cosecant. So I'm first going to remind myself what the sine of negative 17 pi over 6 is, which is negative 1/2 because the sine is the y coordinate. The cosecant will be the reciprocal of that. So in this case will be negative 2. So again, my hope here is that all of the sine, cosine, tangent, cosecant, secant stuff was review, and the coordinates were review, but the new idea was how to find that correct position when we weren't talking in radian units, but instead we're giving you, instead of degree units, we're giving you radian units. So that's what we want you to focus on. So the homework's going to look really similar to skill 3, all these same types of questions, but they've been translated from degrees into radians.